Alright, so this question here, we're going to start with some function f of x equals x cubed plus 3x squared minus 8x. The first question here asks us to find the gradient of f of x at the origin. What I've plotted here just on Desmos is this graph f of x. What it wants us to do is to find the gradient of f of x at the origin. Well, the origin would be the point 0, 0. So the first thing we need to do is to differentiate f of x. So to find f dash x, hopefully it's quite straightforward by now. That would just be 3x squared plus 6x minus 8. We want to know the gradient when the x value is 0. So what we need to do is plug in an x value of 0 to find the gradient at that point. So 3 times 0 squared plus 6 times 0 minus 8. That goes to 0, that goes to 0, and we're just left with f dash of 0 equals minus 8. So the gradient of f of x at the origin is negative 8. Graphically, we can think about it this way. The origin is here. And the gradient, we can think about that. The gradient at that point is being a tangent at that point. And that looks like it's negative, so that's a good. And it looks reasonably steep, so it's negative 8 seems like a reasonable answer. Alright, with the next question, find the values of x at which the tangent of the curve makes an angle of 45 degrees with the positive direction of the x-axis. So just interpreting that question on the graph here, what that means is we have to find some point on this line where a tangent to that point would give us a gradient of 1. So if we think about this, take that point there. That looks roughly around whereabout we would get a gradient of 1. And if we stretch this all the way out down to the x-axis and extend this, what we're looking for is this angle in here to be 45 degrees. Okay, so that's the question that we're up against, and essentially what we need to do is we need to find the x value of the point, where if we put a tangent at that point, it would give us a 45 degree angle with the x-axis. So what we need to do is set the derivative equal to tan of 45 degrees. So we've got f dash x equals 3x squared plus 6x minus 8. And what we need to do is set that equal to tan of 45 degrees. And let's have a quick think about that. What does that mean? Well, if we think about axes here, x and y, and we need a gradient of 1. So what would that look like? Maybe the line y equals x. We know that has a gradient of 1. Why does it have a gradient of 1? Well, let's say this point here is 2, and this point here is 2. We can see that this angle in here, using our basic SOHCAHTOA, would be tan, if my pen would work, tan of some angle equals, well, tan is opposite over adjacent, so that would be 2 divided by 2. Well, what is that angle? So what we can do is we can put that in the calculator. We can say tan inverse of 1. Whoops. Tan inverse of 1. And that gives us an angle of 45 degrees. So what we're saying is that for the angle to be 45 degrees, then the slope, the rise and the run of that line has to be the same so that it equals 1. So bringing it back to the question here, what we can see is that we have to 3x squared plus 6x minus 8 must equal 1 because the gradient must equal tan of 45 degrees, and tan of 45 degrees is 1. So if we solve this using a quadratic, it gets us 3x squared plus 6x minus 8 minus 1 would be minus 9 equals 0. Okay, then what we can do is we can take a 3 out as a factor if we really want, put big brackets, and it'll give us x squared plus 2x minus 3 equals 0. 3 still at the front. Alright, what number multiplies to give negative 3 and adds to give positive 2? It's going to be x multiplies to give minus 3, so AC equals minus 3, B equals 2. Well, that's going to be 3 and 1. It's going to be 3, and it's going to be negative 1. So that's going to be x plus 3 and x minus 1. Solving this now, divide everything by 3, just gives us x plus 3 and x minus 1 equals 0. And solving that using the null factor law gives us x equals negative 3 and x equals 1. So at these points here, the tangent at these points would make a line that has an angle of 45 degrees with the x-axis. So if we have a look here, one of our options was 1. So if we look for the point x equals 1 on the graph, x equals 1 is about there. My pen would work. X equals 1 about there. And we can see that if we do a tangent at that point, that means that this angle here is 45 degrees. So essentially all we've done in this question is we've said that the derivative function, aka the gradient, must be equal to tan of 45 degrees. And that gives you your answer of x equals negative 3 and x equals 1.